guys, let's look at the next question. The next question that we do is question number 13. It says find the length of BC, AD and AC and certain things are given. So we have two right triangles here, in fact three, the bigger one ABC and two small ones BCD and ABD. So BC is a part of the big right triangle. So in right triangle ABC, what I have is for this is perpendicular and BC is the base. So tan 30 degree is equal to AB upon BC, and tan 30 degree is equal to 1 upon root 3, which means 1 upon root 3 is equal to 12 upon BC, which means BC is equal to 12 root 3 centimeter. And if I multiply 12 with 1.732, my answer that I get is 20.784 centimeter. Therefore, BC is equal to 20.784 centimeter. So the first part of the question done. Let's look at the second one, which is here again I'm repeating, I've taken root 3 as 1.732. Next, AD. So AD is a part of my small triangle ADB. So I need to have a reference angle. So this in the big triangle will be 60 degree. Why? Because angle sum property, this is 90, this is 30, which means angle A is 60 degree. Let's just write this down. So in a right triangle ABC, 90 degree plus 30 degree plus angle A is equal to 180 degree. Therefore, angle A is equal to 60 degree. I need to calculate AD. So in this right triangle ADB, this is adjacent and this is hypotenuse, which means I'm looking at cos. So in right triangle ADB, I have cos 60 degree is equal to base, which is AD, upon hypotenuse, which is AB. So cos 60 degree, the value of cos 60 degree is half. So half is equal to AD, which we do not know, and AB is 12. Therefore, AD is equal to 6 centimeter. So the second part of the question done. AD is equal to 6 centimeter. Let's look at the last part of the question, which is AC. So this is equal to 6. We got BC as equal to 12 root 3. Next, we need to find AC. So we are again looking at the big triangle ABC. So point number 5, in a right triangle ABC, I have reference angle 30 degree. This is perpendicular. This is hypotenuse. So I'm looking at sine. So sine 30 degree is equal to AB upon AC. Sine 30 degree is equal to half. So half is equal to 12 upon AC, which we do not know. Therefore, AC is equal to 24 centimeter. Done. We've calculated all three parts. The only new thing in this question was to apply the angle sum property in the big triangle and figure out that angle A is 60 degree. Let's look at the next question. The next question that we do is question number 50. It says a ladder is placed against a vertical tower. So let's just draw a rough diagram for this question. This is my vertical tower and this is the ground. Vertical tower would mean that I am making an angle of 90 degree. Like I said earlier as well, in any question related to Pythagoras theorem or trigonometry, marking this angle 90 degrees is extremely important. So ladder is placed against a vertical tower. So let this be the ladder. Let me just write this down. This is ladder, this is tower, and this is ground. Let's give them some names. Let this be point A, point B, and point C. So a ladder is placed against a vertical tower if the ladder makes an angle of 30 degree with the ground. So this angle A here is given as 30 degree and reaches up to a height of 15 meter, which means BC is given equal to 15 meter. Now we've converted the word problem into a trigonometrical question, which looks simple now. We need to find the length of the height of tower, find the length of the tower. Is that the question? Find the length of the ladder, obviously, because the length of the height of the tower is already given. So this is, I have written the question incorrectly. We need to find the length of the ladder. So I need to find AC. Okay, so I have, for this reference angle, this is perpendicular and this is hypotenuse, which means I am looking at sine. So in a right triangle ABC, what I have is sine 30 degree is equal to BC upon AC. Sine 30 degree is equal to half, which is equal to BC, which is 15, and AC we do not know. Therefore, AC is equal to 30 meter. Therefore, length of ladder is equal to 30 meter. Oh, that's quite a long ladder. 30 meter is a very long ladder. Good. We've learned one new skill of converting English in the form of word sentence or a word problem into a diagram based on trigonometry, and marking this 90-degree angle extremely important. Not marking this will cut 1 mark for you in an ICSE exam. Let's look at question number 16. A kite is attached to a 100-meter long string. Find the greatest height reached by the kite when its string makes an angle of 60 degree with the level ground. Okay, so again, let's try and draw a rough diagram for this. So this time, let's draw this 90 degree. This is ground. This is my last point of the kite. This is the string. The string is 100-meter long, which means this time the hypotenuse is given. Find the greatest height reached, which means this is the length that I have to find, and this is 60 degree. Perfect. Let's just check the question if I have done it correct. 100-meter long string. So this is the string. Greatest height. This is what I need to find. An angle of 60 degree. So in right triangle ABC, let's see which ratio I need to calculate. I have hypotenuse and I have to find perpendicular, which means sine 60 degree is equal to BC upon AC. Sine 60 degree is root 3 upon 2. So root 3 upon 2 is equal to BC, which we need to calculate, upon AC, which is 100. Therefore, BC is equal to 100 root 3 upon 2 meter. This is 250. Therefore, BC is equal to 50 root 3 meter. Let's just calculate 17.32 multiplied with 5. That's 5 into root 10. 15 plus 1, 16. 35 plus 1, 36. That's 8. Therefore, BC is equal to 86.6 meter. Let's look at the next question. Question number 17, part 1. It says find AB and BC. We have two right triangles visible. Let's look at the first triangle. So number 1, in right triangle ABC, I have tan 45 degree is equal to AB upon BC. Tan 45 degree is 1, which means AB is equal to BC. Let this be equal to X. So AB and BC are equal, and let this be equal to X. Next, let's apply trigonometrical ratio in the bigger right triangle. So that's point number 3, in right triangle ABD. So I have tan 30 degree is equal to AB upon BD. Tan 30 degree is equal to 1 upon root 3. AB is X and BD is BC plus CD, which means X plus 20. Let's cross multiply. So I have X root 3 is equal to X plus 20, which means X root 3 minus X is equal to 20. Let's take X common. So X times root 3 minus 1 is equal to 20, which means X would be equal to 20 upon root 3 minus 1. Let's rationalize this, multiply it and divide it by root 3 plus 1. So this becomes 20 times root 3 plus 1 upon x square minus y square, in this case 3 minus 1, so that's 20 times root 3 plus 1 upon 2, that's 2 1 2 10, so this is 10 times 1.732 plus 1, which is 10 times 2.732, therefore x is equal to 27.32 centimeter. Therefore AB is equal to BC is equal to 27.32 centimeter. That's what we had to calculate. Done. Let's look at the next one. The next question that we do is question number 17, part 3. Again, find AB and BC. Again, we have two right triangles, so let's look at the bigger triangles. So number 1, in right triangle ABD, we have tan 45 degree is equal to AB upon BD. Let AB is equal to X, let BC is equal to Y. So what we have is AB is equal to BD. Yes, AB is equal to BD is equal to Y plus 20. Let's check if this is correct. Yes, AB and BD are equal. If this is X and if BC is Y, then this is equal to Y plus 20. Done. Let's look at the smaller triangle. So in right triangle ABC, we have tan 60 degree is equal to X upon Y. Yes, tan 60 degree is equal to AB upon BC, which is equal to X upon Y. Tan 60 degree is root 3. So root 3 is equal to X upon Y, which means X is equal to Y root 3. So let's see if I have anything else. We need to have another equation. So we have X is equal to Y root 3, and we got AB is equal to BD is equal to Y plus 20, and this is equal to X because AB is equal to X. So what we have is X is equal to Y plus 20, and we have, this is equation 4, this is equation 5. X is equal to Y root 3 and X is equal to Y plus 20. So let's replace the value, which means Y plus 20 is equal to Y root 3, which means Y root 3 minus Y is equal to 20. Y times root 3 minus 1 is equal to 20. Oh, this is the same calculation as the first part. This will again work out to be 27.32, which means Y is equal to 20 upon root 3 minus 1. Rationalizing gives me multiply with root 3 plus 1, divide by root 3 plus 1. This is 20 times root 3 plus 1 upon 2. Therefore, Y is equal to 10 times 2.732. Therefore, Y is equal to 27.32 centimeter. So what we have, so BC is equal to 27.32 centimeter and BD is equal to 27.32 plus 20 centimeter, which is 47.32 centimeter. We already know AB is equal to BD is equal to 47.32 centimeter. So we've got the value of AB as well, which is 47.32, and we got value of BC as 27.32 centimeter. Done. Let's look at the next question. The next question that we do is question number 19. So question number 19 says tan x is equal to 5 upon 12 and tan y is equal to 3 upon 4 and AB is equal to 48. Find length of CD. So for both x and y, this is the perpendicular, which means we are looking at again tan. So let's just write this down. In right triangle ADC, point number 1, what I have is tan x degree is equal to DC upon AC, which is given equal to 5 upon 12. Yes, so does this mean DC is equal to 5? No, this is a ratio. There is a common factor. Let's say this is, therefore DC is equal to 5L and AC is equal to 12L. Yeah, so this is 5L and AC is 12L. Why have I taken it as a factor? Because this is not equal to 5 directly, it is a multiple of 5 because this is a ratio. Next, let's look at the second triangle, which is triangle BCD. So in right triangle BCD, I have tan Y is equal to CD upon BC. This is given equal to 3 upon 4. Again, this is not equal to 3 and 4. The CD is not equal to 3. It's a factor of 3. So let's constant in this case, let it be L. Oh, sorry, L already taken, M. Therefore, CD is equal to 3M and BC is equal to 4M. So this is 3M and BC is 4M. So we have taken two factors, L and M. What I have is from 2 and 4, I have CD is equal to 3M is equal to 5L, which means the equation that I get is 3M minus 5L is equal to 0. So that's the first equation that I get, 3M minus 5L is equal to 0. So this is 3L and 5M are equal. Let's see what's the second equation that I get. So this is 12L, which is equal to 4M plus 48. Yes, 12L is equal to 4M plus 48. Perfect. Let's just write that down. Point number 7. From 2 and 4, I also get 12L is equal to 4M plus 48. Let's put this in the form of M minus L. So this will be 4M minus 12L is equal to negative 48. Anything common? Yes, 4 is common. So let's divide this by 4. So this is 3M minus, sorry, not 3M. Divide by 4 would give me M. M minus 3L is equal to negative 12. So that's the next equation I get. M minus 3L is equal to negative 12. Let's multiply this with 3 because this will make my coefficient of M equal. So 3M minus 5L is equal to 0 and this is 3M minus 9L is equal to negative 36. Let's subtract negative plus positive and I have 0. Negative 5L plus 9L, that's 4L is equal to 36. Therefore, L is equal to 9. So the constant is 9. Let's see what do we have to calculate. We need to calculate CD. Therefore, CD is equal to 5L is equal to 5 into 9. That's 45 meter. Done. So CD is equal to 45 meter. We calculated, since there were two ratios given, we calculated two equations and then we equated them. That brings me to the last question of this chapter. The last question of this chapter is question number 20. The perimeter of a rhombus is 96 meter. Let me just draw a rough diagram quickly. This is a rhombus, which means all four sides are equal. So A, B, C and D is 96. Okay, so point number 1, perimeter is equal to 96 centimeter. Therefore, each side is equal to 96 upon 4, which is equal to 24 centimeter. So each side is 24 centimeter. Done. Obtuse angle is 120 degree. So this is 120 degree. Find the length of the diagonal. So we need to calculate AC and BD. We've done a question like this. I think question 6 was similar. Let the point of intersection of the diagonals be O. Diagonals of a rhombus bisect each other at 90 degree, which means OD and OB are equal and OA and OC are equal. And the diagonals also bisect the vertex angle, which means this is 60 degree. Let's just write all this down. Point number 2, diagonals of a rhombus bisect each other at 90 degree. What this means is, point number 3, therefore OD is equal to OB and OA is equal to OC. Next point, diagonals of a rhombus bisect vertex angles. Therefore, angle ABO is equal to angle CBO is equal to 60 degree. Now let's look at the right triangle BOC. So in right triangle BOC, I have one side as 24. This is my reference angle. So this is perpendicular, this is hypotenuse in this case, and OC would be the perpendicular, which means sine 60 degree would be equal to perpendicular, which is OC, upon hypotenuse, which is BC. Sine 60 degree is equal to root 3 upon 2. So root 3 upon 2 is equal to OC, which we don't know, and BC, which is 24. What this means is OC is equal to 24 root 3 upon 2, which is 12 root 3 centimeter. Therefore, OC is equal to 12 into 1.732. Let's just multiply 1732 into 12. This is 2 into 2, 4, 2 into 3, 6, 2 into 7, 14, 2 into 1, 2 plus 1, 3. This is 2, 3, 7, 1. This is 4, 8, 7, 10, 2. 3 decimals, so that's 20.784 centimeter. Therefore, OC is equal to OA is equal to 20.784 centimeter. Therefore, AC is equal to 2 times this, which means 2 into 4, 8, 2 into 8, 16, 14 plus 1, 15, that's 1, 4. So that's 41.568 centimeter. So one diagonal we've calculated, it's 41.568. Now again in a right triangle BOC, let's this time calculate cos. So cos 60 degree would be equal to base, in this case OB, upon hypotenuse, which is BC. Cos 60 degree is half, so half is equal to OB upon BC, which is 24. Therefore, OB is equal to 12 centimeter, which means OB is equal to OD is equal to 12 centimeter. Therefore, BD is equal to 24 centimeter. So the second diagonal is 24 centimeter. Let me just mark some homework questions for you. Homework question for you would be question number 14 and question number 18. Thank you so much. Take care. Be safe. Bye bye.